November 1930. Lemaitre Station, central Greenland, 400 kilometers from the coast, at an altitude of 3,000 meters in temperatures that had dropped below -50 degrees Celsius. Alfred Wegener left that camp on November 1st to make the return journey to the western coast. He was 50 years old. His team watched him go. Fritz Loewy, frostbitten and unable to walk, watched from inside the tent as Wegener and the Greenlander guide Rasmus Willemsen harnessed the dogs and moved into the white. They never arrived. Wegener's body was found the following May, halfway between Lemaitre and the coast, carefully buried in the snow by Willemsen, who marked the grave with skis. Willemsen himself was never found. The official report filed by the surviving expedition members noted the cause of death as heart failure brought on by exertion. It did not note what Wegener had spent 30 years trying to prove. The report was a witness document, and like all witness documents, its silences were as precise as its words. Wegener had published his theory of continental displacement in 1912. The argument was not speculative. He had assembled it from 5 independent lines of evidence: the geometric fit of the continental coastlines, the matching fossil records on either side of the Atlantic, the identical rock formations in Brazil and West Africa, the paleoclimate data showing coal deposits, tropical vegetation in Antarctica, and the shallow water sediment structures that made no geological sense unless the continents had once been joined. The geologist Edward Suess had already named the ancient supercontinent. Wegener called the breakup Pangaea and tried to explain how it had happened. That last part was the problem. Wegener proposed that the continents plowed through the ocean floor like ships through water, driven by centrifugal force and tidal friction. The mechanism was wrong. Not wrong in a way that made the evidence disappear. The evidence remained exactly as compelling. But wrong enough that the physics establishment could dismiss the entire framework by attacking the mechanism alone. Harold Jeffreys, one of the most respected geophysicists in the world, calculated in 1924 that the forces Wegener invoked were 11 orders of magnitude too weak to move continents. He was correct. The forces Wegener named were indeed too weak. What Jeffreys did not calculate, because the data did not yet exist, was whether there might be a different mechanism entirely. He disproved the explanation. He reported this as disproving the phenomenon. The witnesses at the 1926 American Association of Petroleum Geologists Symposium, convened specifically to evaluate and reject Wegener's theory, filed their reports with confidence. The continents did not move. The evidence that they had was cataloged as anomalous and set aside. Anomalous is the word institutions use for data that does not fit the model they are not yet ready to replace. What I cannot resolve, and I have sat with this longer than I should have, is whether the rejection was a failure of intelligence or a failure of nerve. The geologists at that symposium were not stupid. They were, by the standards of their time, rigorous. They looked at the same coastlines Wegener looked at. They held the same fossil records, and they concluded that the similarities were coincidences or the result of land bridges, now submerged, that had once connected the continents and then sunk. Land bridges. Entire subcontinents sinking into the ocean floor, leaving no trace. The physics of that proposal were never seriously calculated. The mechanism was never interrogated the way Wegener's mechanism was interrogated. Because the land bridge hypothesis fit inside the existing model, it required no new framework. It was wrong in a comfortable direction. Wegener's mistake was being right about the phenomenon while being wrong about the cause. Science has no official procedure for that situation. The official procedure handles the cause. It awarded the cause to Jeffreys and filed the phenomenon under not yet explained. Wegener died on the ice. The mechanism he couldn't name, convective currents in the mantle, driven by heat from radioactive decay in Earth's core, was confirmed by seafloor spreading data in the 1960s. The theory was renamed plate tectonics. Every geology textbook on Earth now contains it. His name appears in the history sections, not usually in the chapter headings. The first obstetrical clinic of the Vienna General Hospital had a problem that everyone could see and no one could explain. Women who delivered their babies in the first clinic died at a rate roughly 5 times higher than women who delivered in the second clinic next door. The mortality was from puerperal fever, childbed fever, a systemic infection that typically killed within days of delivery. In some months in the first clinic, the mortality rate exceeded 10%. In the worst months, it approached 18%. Women in labor who arrived at the hospital gates and learned they had been assigned to the first clinic begged to be sent to the second. Some gave birth in the street rather than enter. The hospital staff knew the disparity. The doctors knew it. The institution had been tracking the numbers for years. What they did not know was why. Ignaz Semmelweis was a 29-year-old Hungarian physician, an assistant in the first clinic in the spring of 1847. He had been studying the mortality data with the kind of methodical attention that data of that magnitude demands. The first clinic was staffed by medical students and physicians. The second clinic was staffed by midwives. He cataloged every variable he could identify. Delivery position, different between the clinics. He changed it in the first clinic. The mortality did not change. Overcrowding, ventilation, emotional distress. There was a theory at the time that the presence of a priest walking through the ward to administer last rites frightened women into susceptibility. He had the priest take a different route. The mortality did not change. Then, in March of 1847, his friend and colleague Jakob Kolečka died. Kolečka had been performing an autopsy and was accidentally punctured by a student's scalpel. He died of an infection that Semmelweis, reading the autopsy report, recognized as pathologically identical to puerperal fever. Kolečka had not given birth. He had been cut by an instrument that had been inside a cadaver. Semmelweis stood in the autopsy room. It was early spring. The windows were probably fogged. The smell of the room was what it always was, and understood. The medical students and physicians who staffed the first clinic came directly from performing autopsies on cadavers to delivering babies. They did not wash their hands. There was no protocol requiring it. The germ theory of disease did not yet exist. Louis Pasteur would not publish his foundational work until 1857. The word pathogen did not exist in the form we use it. What Semmelweis had was a hypothesis that he could not explain at the molecular level and a dataset that supported it with extraordinary force. He instituted a hand-washing protocol in May of 1847. Physicians and students were required to wash with a chlorinated lime solution before entering the delivery room. The mortality rate in the first clinic fell to 1.27% within 2 months. In some subsequent months, it fell to 0. The second clinic's rate remained roughly the same as it had always been. He published the data, he presented at conferences, he wrote letters. The response from the Viennese medical establishment was measured, professional, and negative. Johann Klein, the head of the first clinic and Semmelweis's direct superior, did not implement the protocol permanently. The objections from senior physicians were varied. The theory was unproven at the mechanistic level. The suggestion that doctors were transmitting disease was an insult to the profession. The mortality statistics could be explained by other factors. One prominent critic noted that the mortality in Dublin was similarly low despite no hand-washing protocol, which was true and which Semmelweis could not immediately explain, because the situation in Dublin involved different delivery practices he hadn't yet fully analyzed. He left Vienna in 1850. He returned to Budapest. He continued to write. The letters became more urgent, more anguished, more accusatory. In 1861, he published his major work, a book setting out the complete evidence. It was long, repetitive, and bitter. It was reviewed poorly. He wrote open letters to the heads of obstetrics departments across Europe, calling them murderers. He was not wrong about the deaths. He was not managing the politics in any way that would result in adoption. In August of 1865, Semmelweis was committed to a mental institution by colleagues who had decided he was no longer rational. He was 47 years old. He died 2 weeks later, most likely from a systemic infection, possibly the same type of infection he had spent 18 years trying to prevent. His autopsy showed injuries consistent with a beating. Louis Pasteur confirmed the germ theory 2 years after Semmelweis died. Joseph Lister, working from Pasteur's framework, developed antiseptic surgical techniques. Hand-washing became standard medical protocol. His name is now on hospitals, on medical schools, on hand-washing awareness campaigns. The institution that killed him named things after him. I am not interested in the vindication. I'm interested in the morning before it, when one person knew something true and had no way to prove it and went to work anyway. Semmelweis went to work every morning in a ward where he understood what was happening and could not make anyone else understand it fast enough. He had the data. The data was not in dispute. Klein had access to the same numbers. What was in dispute was the interpretation, and the interpretation threatened something larger than a theory. It threatened a professional identity. Physicians as vectors of disease, doctors as the cause of the deaths they were supposed to prevent. The institution did not reject the data. It rejected the implication. The numbers were noted. The mechanism was declared unproven. The protocol was made optional. The physician's dignity was left intact. Georges Lemaitre was a Belgian Catholic priest and a physicist. In 1927, he published a paper in the Annals of the Brussels Scientific Society proposing that the universe was expanding, that galaxies were receding from each other, and that running this expansion backward implied a beginning, a moment of extreme density from which everything had emerged. He derived this from Einstein's general relativity. He solved the field equations and found a non-static solution, a universe that changes over time. He called the initial state the primeval atom. Einstein read the paper. He met Lemaitre at the Solvay conference in Brussels that same year, October, in the corridor between sessions, Einstein pausing mid-step to deliver his verdict. His response was, "Your calculations are correct, but your physics is abominable." Einstein was not dismissing the mathematics, he was dismissing the conclusion. A universe with a beginning implied, to many physicists of that generation, a creation event, and a creation event implied a creator. Einstein had his own philosophical commitments to a static, eternal universe. He had added the cosmological constant to his field equations, specifically to force them to produce a static solution. When Lemaitre showed him a dynamic one, Einstein's response was not to examine whether the solution fit the observations. His response was to call the physics abominable. Edwin Hubble published his observational confirmation of galactic recession in 1929, 2 years after Lemaitre's paper. In January of that year, Hubble sat at the eyepiece of the Hooker telescope on Mount Wilson and measured the redshift of 46 galaxies. The data showed exactly what Lemaitre had predicted. Einstein removed the cosmological constant from his equations, calling it his greatest blunder, and publicly acknowledged that Lemaitre had been right. Lemaitre's 1927 paper had been published in French, in a Belgian journal with limited international circulation. When it was translated into English and published in the monthly notices of the Royal Astronomical Society in 1931, 2 paragraphs containing his derivation of what would later be called Hubble's law were missing. The editor had removed them. Lemaitre had approved the omission himself. He was characteristically uninterested in the priority dispute. But the result was that the English-language scientific community read a version of his paper that omitted the parts that showed he had derived the expansion rate before Hubble measured it. The law of the expanding universe is called Hubble's law. In 2018, the International Astronomical Union voted to rename it the Hubble-Lemaitre law. Lemaitre had been dead for 52 years. Arthur Eddington was Lemaitre's doctoral supervisor at Cambridge. In the autumn of 1927, Eddington sat at his desk in Trinity College, the same desk where he had worked through the mathematics of his 1919 solar eclipse expedition, and set aside the copy of Lemaitre's paper that Lemaitre had sent him directly. He did not forward it, he did not cite it, he did not bring it to the attention of the international community whose ear he held. In 1930, after Hubble's confirmation was already established, Eddington wrote a paper exploring the possibility of an expanding universe. He credited Lemaitre after Lemaitre wrote to him directly to point out the earlier publication. When asked later why he hadn't promoted the 1927 paper at the time, Eddington said, in effect, that he hadn't taken it seriously enough to distribute it widely. Einstein's framework said the universe was static. Eddington's framework said the significant work happened at Cambridge and in the major Anglophone journals. The editor's framework said that a priority claim by a Belgian priest in a Brussels journal was a footnote, not a headline. None of them falsified data. None of them acted with what they understood to be malice. Each one made a reasonable decision within the model they already occupied. Semmelweis spent the last months of 1864 in his office at the University of Pest, writing the open letters. Not the careful scientific correspondence of earlier years. These were accusations addressed by name to the heads of obstetrics departments across Europe, telling them directly that their practices were killing women. He knew what the letters were doing to his reputation. He wrote them anyway. His assistant later recalled that he arrived at the same hour every morning, sat at the same chair, and worked through the morning without speaking. The ward mortality data from the first clinic in Vienna, the numbers from 1847 and after, was always somewhere on the desk. He was looking at evidence that had not changed. The gap between what the data showed and what the institution had done with it had not closed in 17 years. He had no way to know that Pasteur was already in Paris, that the mechanism was 9 months from publication, that the framework was about to arrive. He went to work. Wegener's last camp on the Greenland ice sheet was marked with crossed skis. The expedition that found his body in May 1931 noted in its report that he had been carefully buried, that the grave was well made, that Willemsen had taken time, in temperatures and conditions that made time an expense, to ensure the body was properly marked. They reburied him there. The ice sheet moves. The grave has since shifted kilometers from where it was placed, under more than 100 meters of accumulated snow. The ice did not care whether he was right.